approach, and it's easy for someone to make a mistake and not follow that approach. So the third way of doing transaction management within Coherence, and by far the most popular, is using something called entry processors. There are a lot of pre-written ones already, but you can write your own, and effectively that means you write a piece of logic you want to run against an object, and you put that on the server side, just like you would with some PL/SQL or some Transact SQL. And then when you want to perform that piece of logic against an object, you make a request from the client. The request is effectively logically queued on the server side against that object, and when your request comes to the front of the queue, you have exclusive access to that object to be able to run that piece of code. The benefit of that approach is all the processing happens on the server side, so the number of network hops is reduced to a minimum. And secondly, the contention for an object is very low because the data and the processing are all running in the same place. The cherry on the cake here is that if your processing fails because the JVM crashes or whatever halfway through your processing, Coherence will rerun that processing automatically on another node in your cluster. So you not only minimize the actual number of network hops, but you also gain failover capabilities in terms of your transaction processing. It's a bit like executing a system PL/SQL where the data and the logic are co-located. So that's by far the most popular and the most efficient way of actually performing transactions in Coherence. You can also interact with the database of Coherence. Typically, your database would sit behind a cache, and you can do something called read ahead or read on demand. Read ahead is where you effectively load the data into a cache from a database prior to actually needing it, and then when the data is just about to expire because you say I only want to keep it for a minute or an hour, then Coherence will read that data in again. Read on demand is when I request some information from a Coherence cache, it's not there, and Coherence in the background can go and fetch that data from the database, load it into the cache, and return it to the client as a seamless operation. Persisting data can be done in a number of ways. You can use write-through mechanism where I write an object to a cache, and in the background, I write an object to the cache, and then synchronously Coherence will write that through to the database. That's typically used if customers perform a whole lot of operations, but at some point they want to ensure that the data is not only in the cache but on a database. You can use write behind, which is a more efficient way where you effectively write your changes into a cache, and then periodically, depending on the time frame you've set, a couple of seconds, a couple of minutes, Coherence groups together all those changes and writes them down to the database. That reduces the load on the database and can significantly improve performance because you're not waiting for the database to persist every change. With updates, it can coalesce them, so very highly updating data can be compressed. If you have 10 updates in a second and you're persisting your data in the background every second, you'll only write the latest update every second. If you have multiple inserts, you can do a batch insert to the database, again, which reduces the load on the database. Serialization is perhaps a slightly esoteric topic, but the benefit of serialization is that, so the thing about serialization is every piece of data which needs to be sent or fetched from a Coherence cache needs to be sent across the wire. So the objects need to be turned into a byte stream and sent across the wire. The standard Java serial, because Coherence is based on Java on the server side, and the standard Java serialization mechanism, while it's easy to use, is very inefficient in terms of the size and the speed of serializing and deserializing the data. Now, if you're storing your data in memory, or you're reading and writing the data very quickly or very frequently, that can have a big impact on your performance. Now, this graphs you can see are just a typical example. Tangosul and Coherence since went through a number of iterations of looking at different approaches to optimizing serialization. And the one we've settled on is our portable object format, and the standard for that we've actually published as well. But what that is, it's a language-neutral wire format for serializing data. It allows you to serialize the data in a much smaller format than the standard Java serialization mechanism. So you can squeeze down 5 times as much data into the same space. Although memory is cheap, it's not that cheap, and so getting 5 times as much data in memory is something which adds a lot of value to Coherence. Also, being able to deserialize the data 10 times faster than the standard Java serialization mechanism. Again, if you're having to deserialize information a lot of the time to look what's in it, to do a query or something, then again that can have a big impact on performance. And just to touch on the other aspect of serialization, if I'm a .NET client and I'm talking to a cache, coherence cache that's obviously written in Java, the way things work is that you typically would have a .NET object and a corresponding Java object. And when you turn the .NET object or even a C++ object and send it across the wire, what you effectively do is you encode that object in a portable object format, which is language neutral. It gets sent across the wire, and the other side, the Java object would deserialize that wire format object and store it in a cache. And that's how the different languages can all communicate with each other. So I can have a Java client put an object in the cache, and a C++ object take it out, and a .NET object perform a query against that object, because they're all using portable object format as their common denominator in terms of they all understand this, and this is how Coherence can support multiple languages. Other features Coherence supports are HTTP session caching. So, for instance, if you're either a .NET or a J2E user and you run J2E applications or ASP.NET applications, your session state can be cached in Coherence, and Coherence supports this without any changes to either your ASP.NET application or your J2E application. And it provides a number of features, and one of the key ones is you basically take the state out of your web application, you put it in Coherence, so you can then shut down or start up your .NET or your J2E application without requiring any users to be logged off, because users can be rerouted to another J2E application server or another IIS instance, and they can all access the same information. The other thing you can do is you can reduce the memory footprint of both the J2E and the IIS applications, because they're not having to hold lots and lots of old sessions where users haven't logged out. It's a very optimal way of managing resources. You basically put those sessions in Coherence. We can also provide out-of-the-box plug-in caching for both Hibernate as an L2 and a query cache. And this is very useful if you've got lots of information and you don't want to necessarily replicate it as you would with EH-cache. There's a plugin for Coherence with Enterprise Manager, Oracle Enterprise Manager. So if you're an Oracle database user and you're used to using Enterprise Manager to manage your database, you can install the plugin for Coherence and manage your Coherence cluster using the same interface. So you have a web console to find out how much data is in your cache, how it's performing, all the metrics that are available. If you use Toplink, there's integration for Coherence using Toplink, so you can have an entity manager which can not only look at the data in a database and perform queries against the data in the database, but it can also do the same with Coherence. And you can combine the two as well, so you can have some queries run in Coherence, some queries are run against the database. All the metrics around Coherence, how it's performing, etc., are available through JMX. There's literally hundreds of different metrics you can look at. And finally, there's a rich set of security features. So we can not only encrypt data on the wire, we can restrict who can access a cluster, who can join a cluster, a whole range of security features which can be applied to a cluster to ensure only those people who can access it should access it. Or so, rather the other way around, should access it, can access it. A couple of other points I wanted to mention are Tera-Scale grids. One of the new features of the Coherence is we can actually store the cache data not on the heap but outside of the JVM using the Java NIO features. So that allows you to actually have very, very large caches. Not everybody needs this capability, but you can have caches which go up into the terabyte range. So for some customers, that is a use case they're interested in, because they do want to store very large amounts of data in memory to provide fast access to it. There are also a whole range of what we call